Okay, let's sort of consider a more concrete case. Consider some of the operating systems we currently have or had in case of MS-DOS. Thank God. So what exactly I said, the OS portion and the user portion of the address space, how does it work in these systems? So for example, if you look at the address space layout for 32-bit Linux, lower 3 gigabytes is where the user code data is going to go. So address space is going to be 4 gigabytes long with 32 bits. So we're going to separate that, say 1 gigabyte for the kernel and 3 gigabytes for the user. The lower 3 gigabytes, that's where the user code data is. The top 1 gigabyte is where the kernel goes, and there's this fence between these two. The kernel portion can only be accessed when you are in the operating system or in the kernel. Okay, another thing to keep in mind is that these portions of address space that we have, access to those address spaces also is related to what execution mode or privilege ring you are in. So x86 has the 0 through 3. For you to be able to access the kernel portion, you have to be in ring 0 or system mode. If you are executing user code in ring 3, you can't access this portion of the address space that we have, which is the 1 gigabyte. So this connects back the hardware support that we have and the address space layout that we're talking about. So these other operating systems, depending on what particular version, may have some differences, but typically this is how it works. The operating system is common. So this kernel 1 gigabyte has the same data and code for every process. But the 3 gigabyte is per process, obviously. This is could be different for different processes. And we said if you're executing this part of this 3 gigabyte, then you are in ring 3. If you're executing the kernel, you are in ring 0. This is how operating systems manage access to various parts of the address space. Well, so modern operating systems actually separate the trusted computing base from untrusted. It wasn't always like that. If you look at MS-DOS, and actually now it's in a museum, Microsoft even the first version they made the source code available, actually written in assembly language. It didn't have the separation that we're talking about. There was no sort of fence or wall between the user and system code. So any process could actually alter the operating system because you can freely march down into the OS space. And if you happen to be a virus, you obviously could hook anything, including, here it talks about interrupt handlers actually are always in the operating system. We're talking about dealing with hardware devices, and direct access to hardware is through privileged instructions, not from user level. Those instructions have to be privileged. So here you could actually, change the kernel, change the interrupt handlers. There was no protection that modern operating systems provide through this isolation of the operating system from application code.